This lecture is on conjoint analysis. Conjoint analysis is a technique that can involve several multivariate analysis approaches. Conjoint analysis is also called trade-off analysis. It assumes that a product can be conceptualized as a bundle of attributes. And it's very unlikely that any one product will have the ideal level of the attribute. Consumers are forced to make trade-offs. I'd give up some of this attribute in order to get that attribute. And the question for those who want to design products is how important are attributes? That's the most important attribute. What should I make sure my product has? And to answer that research question, one might use direct measures. Just simply write questions that ask how important is this attribute, or how important is that attribute, and scale those on a very unimportant to extremely important scale, for example. And one sees the use of those measures often in attitude questionnaires, where one asks beliefs about specific attributes. Do you believe brand X has attribute 1? And with a paired question, how important is attribute 1? But as with attitudes, asking those specific dimensions doesn't yield a score that picks behavior as well as asks a holistic attitude. How valuable is this brand? How attractive is this brand? So in conjoint analysis, one starts with an overall judgment and use an indirect approach to come up with the importance of each individual attribute. So that indirect measurement, as was true with attitude modeling, is called a decompositional approach, or a decompositional model, decomposing the overall score into specific utilities. So conjoint analysis starts by making an overall judgment and then using statistics to explain those judgments with specific attribute preference weights. There are three sort of category objectives of conjoint analysis. The first is to identify the utility of attribute levels, to drill down into the overall evaluation, identify the specific values or the specific weights of attribute levels. Then, once that's done, the range of utilities across those attribute levels can be used to reflect the importance of the attribute overall. Basically, an attribute that has a wide range of utilities is one that's important. If you think of importance as the risk associated with making the worst decision relative to the best decision. Well, if that range is very large, then the risk is very high. So to identify the product overall, or to compare products overall, and the utility of a product is the sum of the utilities attribute levels that comprise that product. And to predict market shares or to predict just intention of product configurations. So once we have utility levels or attribute levels, we can consider a product of any configuration, and we can estimate the utility of product, and we can compare it with products. Conjoint analysis can be used or adapted to most products. All it takes is the ability to identify discrete, important attributes. And these are some examples. Car tires can be thought of as some combination of brand, tread life, price, and design. Credit cards, the important attributes are interest rates, annual fee, brand, and bonuses. laptops, brand, processor speed, bundled software, price, ports. Salsa, brand, price, size of the jar, color, spiciness. Sports team logos, vividness of colors, size of city font, size of team name font, with or without a mascot. Soap, whether it's a moisturizer or a cleaner, whether it's manly or feminine, the color, the fragrance. Let me go through an example here to illustrate the process of conjoint analysis. So the problem here is a health club that is expanding or being modified, and one choice or one way to think about how they spend their money is to offer sauna or to enlarge lockers in the locker room. So the question is, which of those is going to go over best with members or potential members? What do people prefer? How do people make the trade-off between those two? So how do people rank attribute combinations? Now if we think of only two levels for sauna, it either has sauna or it doesn't have a sauna, and three levels for locker size, small, medium, and large, then conceptually what we're doing is asking people to rank all of the configurations, and these are results for one individual. The number one ranked most preferred combination is medium-sized lockers with a sauna. The second preference is for small lockers with a sauna. And then the third is for medium-sized lockers but no sauna. Likewise, the fourth, small and no sauna, and then fifth and sixth, respectively, large locker with a sauna or no. So these data could be collected, giving an individual the 6 different combinations, separate cards, and asking him to rank them, to put in order of his preference. The same ranking data could be developed other ways. We'll talk about momentarily. The next step in the process is to use those rankings to compute the utility of attribute levels. So this is a number that reflects the contribution or the value of each attribute level to the ranking. Remember, the ranking is this overall judgment. So here I've taken the ranks of the combinations and converted them to a 5-point scale. So the number one ranked combination, you recall, was a medium-sized locker with a sauna. And I've given that rank highest value 5. The second preferred, most preferred combination was small locker with a sauna, and I've given that a 4. And so on down to the least preferred combination, which was large locker with a sauna, that gets us a 0. And from that, I've computed the marginals. This is the column on the right, the average score. And that's the average value for that attribute level. So you see that average value of having small lockers is a 3. It's 4 in one instance and a 2 in the other. Average value for medium-sized lockers is a 4, and the average value for large lockers is 0.5. And then for the average value having a sauna is 3.33, and the average value for no sauna is 1.7. We can use those utility weights to we can demonstrate the utility will perfectly predict the rankings they came from. So this table shows those utility scores, and if we add the utility for each attribute level to come up with an overall product utility, and then rank those in order. You can see that the utility rank reproduces the original ranking of products. So the combination of medium sauna or medium-sized locker with a sauna has a total value of 7.3 coming from 4 points utility from the medium-sized locker, and then 3.3 from having a sauna. And it's the highest overall score, so it gets ranked number 1. The combination of a small locker and a sauna has a total of 6.3 coming from 3 points for the small sauna and 3.3. I'm sorry, 3 points from the small locker and 3.3 from the sauna, and that's the highest. And so, as you can see, the lowest preferred, least preferred alternative of large lockers and no sauna has smallest overall score of 2.2, and its overall utility rank is just exactly what it was ranked to begin with. So the Health Club example illustrates how overall judgments, in this case rankings, can be decomposed into utility weights for each attribute level. And of course, since that's how we got the attribute levels, if we go backwards, we can use those utility weights to explain the original judgments. Now, in more complicated situations with more attributes and more levels, I'll show you how that can be useful for making judgments about additional configurations of products.